So here's my first slide. Microsoft loves OPC-UA. Any questions? No, seriously, the reason why we think OPC-UA is the future of the industry, any industry, in fact, is because it's platform independent, as we've heard a couple of times today. It's protocol independent, so you can stop talking about is OPC-UA better than MQTT. If you want to run MQTT for your OPC-UA application, you can, right? MQTT is a transport protocol. OPC-UA is an application level protocol. It defines a lot more than just a transport. It comes with an information model that we heard a lot about today. A lot of folks just use OPC-UA because it defines the way you should format your data. So that alone is a non-trivial task. OPC-UA solves that for you. And it's secure. It handles encryption and authentication. In fact, in my talk today, I'm going to focus on two things. One is what are we doing in Microsoft with OPC-UA? And the other aspect I'm going to cover is some security considerations for OPC-UA. And it's open source. It's on GitHub. You can use it free of charge. Look at the source code. Implement your own application. And once you have a commercial product, you become an OPC-UA member. You don't have to build your sources anymore. So the business model of the OPC Foundation is pretty good. The other part that I haven't actually on the slide, but it just occurred to me, what's also really good is OPC-UA strategy is one of collaboration rather than competition. So there are a lot of other IoT protocols out there, or let's say, you gotta help me with this keeps disappearing, I didn't do it. There are a lot of other let's say, protocols out there that are really also pushing into the IoT space. Once they become interesting, the OPC Foundation collaborates with that other industry forum or whatever it may be, creates bridges so you don't have to throw away your OPC-UA application to go into different markets. You just use the bridge. So that's an important part for a lot of companies. So we can, certainly use OPC-UA in other verticals, but industrial automation. In fact, it's in use today in windmills and oil rigs and all sorts of other verticals. And now I really need my next slide because I'm out of talking points. I blame Windows, really, for the problems we're having right now.
I don't want to say anything.
I'm sure it's a Microsoft problem. So the next slide, which you will hopefully see in a second, is our architecture slide. And one thing that just occurred to me as well while we're having the security discussion is, obviously, IoT and OPC-UA with IoT doesn't mean that you have to connect your OPC-UA server to the public internet. In fact, in our reference architecture, the OPC-UA server stays behind the firewall. The firewall remains closed to the outside. The only port that you need from the inside out is port 443, which is the secure socket port. On the cloud side, obviously we have the ability to run OPC-UA servers and clients on Azure, but they're again behind what we call our cloud gateway. It's called IoT Hub. IoT Hub gives you...
I have to put the other microphone for you.
Okay.
For the video. I can put it in here.
Alrighty, I'm definitely wired now. I feel like an IoT device. Okay. Next slide and next slide. Perfect. So where's my laser? There's my laser. So for OPC-UA applications that are running on the cloud or in the cloud, you have this thing in between, the public internet. The public internet is here, right? Right here. So the OPC-UA clients and servers are not visible to folks that are trying to, get in onto your OPC server running in the cloud. And we have a significant number of security experts that their sole job is to prevent hackers getting in on Azure worldwide. So we have a cybersecurity lab. We actually try to hack our own system constantly. We have role-playing games where part of the Azure team becomes the hackers and the other part becomes the people trying to prevent attacks. And we do those on a regular basis. We do scale testing, obviously, and all those things, so you don't have to. That's our message. We charge you for hosting on Azure on a pay-per-use basis. So if you use little, you pay less. If you use a lot, you pay a little bit more. But fundamentally, you don't have to worry about all the security aspects of it because we do that for you. So from Stefan's, he had actually a similar slide to this. So from Stefan's slide, the difference is this new thing here, which we call the Field Gateway. It's actually an SDK. It's open source. It's going to be generally available in a month. And from the get-go, it'll have OPC UA support. So we have 2 modules. It has a modular interface, so you create new modules for the pieces that you want, for the protocols or for the fault tolerance or whatever you want to build into it. But the 2 components that we're going to contribute to the Field Gateway SDK, of course, open source, is what we call the OPC Publisher, which is our pub/sub implementation. It's, to my knowledge, compatible or compliant with the pub/sub specification, but as soon as the pub/sub specification is fully released, we're obviously going to go back and make sure it really is compatible or compliant. And the other part here is the IoT proxy. What that allows us to do is to have OPC UA servers in the cloud talk to factory OPC servers through IoT Hub and through the proxy, which acts on behalf of the OPC servers, and do command and control back into your factory or back into your industrial setup in a secure way. All connections are established from the inside out. So the firewall, which will be here, remains closed, like I said, but fundamentally you have full control of what data gets published to the cloud, and also what devices you want to make available to OPC UA applications running in the cloud. So at the last OPC day in Munich, I announced that we're going to contribute a .NET standard OPC UA reference implementation to the foundation on GitHub. We've done that. It's available now. We're seeing quite a lot of traffic on GitHub, which is great. We have over 250 views every week and over 25 unique clones. So there's a lot of people checking it out, which is awesome. We are taking contributions. So when you do try it out, you find something, there's an issues link that you can click, open a new issue. We're looking at them on a daily basis. We're also in the process of getting our OPC logo for the .NET stack. Obviously, we're running through the tests that Stefan referred to. It's in our interest to make this stack production quality. Right, that's our goal. We're working towards that, and getting the certification is part of that goal. So what is .NET Standards? If you haven't heard of it, it's a new API specification for .NET. It doesn't define a platform. It just defines an API. And then you can get runtimes that support .NET Standard. And those runtimes are for specific platforms, right? So the Universal Windows Platform is a runtime that is .NET Standard compatible. So that means if you use this stack and our reference implementation, you will run on all Windows 10 devices, including HoloLens, the phone, what have you. Or you decide to run an ASP.NET application on Azure. So you can run OPC UA clients and servers on Azure, just as if they were running on your local PC. And there are some interesting use cases there that we're currently working on. And then, of course, it also supports Xamarin and the old, quote-unquote, old .NET framework. So anything that you have from older incarnations of .NET, all of these platforms are supported, but also iOS Linux, and Android. So just so you know, it means there are no if-defs in your code. It's one code base, one application, and through Xamarin, one user interface, and it's completely cross-platform. It runs on anything. And I think that's pretty cool. So that is our .NET Standard story. However, obviously sometimes devices are so small that they can't actually run a whole OS. So, for real-time devices or simple sensors, there's an ANSI C stack. Unified Automation and ASCOLab have a commercial version of that you can go to. And for the publisher and the relay, the two components that you need on the device or on the gateway, if you have a separate gateway device, they will support the ANSI C stack. So we actually have publishers implementations that we've finished. They're on GitHub. You can have a look at them. And the only difference between our publisher or PubSub implementation to a lot of other PubSub implementations is we don't actually run on the OPC server itself, but we have implemented an OPC client that connects to an existing OPC server and then does the PubSub on the client. The big advantage there is you can use PubSub with existing deployments. You don't need to change anything on the server. You don't even need to turn it off. And we get that all the time. We get factory owners that say, yeah, you want to do machine learning in the cloud? Please connect my factory to Azure, but don't make any changes. So to do that, we needed to obviously get a PubSub implementation on another device that you can just add to your factory, which connects to the running system and does the PubSub there. We think that's a pretty good way of doing it. The customers we talked to think so too, because again, you don't need to make changes to your servers. For new servers, it makes absolutely sense to integrate the whole thing on the server, right? You might as well save yourself another device that you need to pay for. But, it depends on your use case. So what's our roadmap? So again, I mentioned the .NET Standard Stack is available on GitHub. We have publishers for all reference stacks, including Java and .NET. We also actually pushed a telemetry website up there, which is very basic. It just basically takes telemetry data that you send to the cloud and displays it in a table. Very simple, but it shows how the whole end-to-end story works, from OPC server, through the publisher, through IoT Hub, and then on display on a website, which obviously is running on Azure. So it gives you an idea of what the chain looks like, what you need to deploy, and then you can take that as a sample for an application or a portal or line of business application that you want to host on Azure. So the whole thing is there, open source. Again, we have OPC running on HoloLens. I have a great picture from HMI this year where Hans Becker was wearing a HoloLens playing with the OPC application that's running on it. The applications themselves, like I said, .NET Standard is cross-platform. It runs on Azure, which means that we can now run servers and clients on Azure. And we're working with a number of customers on a few use cases on why this would be a good idea. And then finally, I think Stefan mentioned it, IoT Hub is available on the German cloud, which means that if your customer says, hold on, my data has to stay in Germany for legal reasons, you can now do that. So you can deploy an IoT Hub on the German cloud and use it just as you would on any other cloud. The only legal difference is the data center is not run by Microsoft, but by T-Systems in Germany. And we have geo-redundancy. We actually have 2 data centers in 2 different places in Germany. So if you need that geo-redundancy for, again, fault tolerance or whatever reasons, you can do that too. What's coming soon? I already mentioned the Gateway SDK is coming next month with OPC UA modules built in. And we're working on the certification. And obviously, we're now also focusing, at HMI I said, listen, we got the plumbing done. We can now connect to OPC UA servers very easily to Azure. Azure is now the best solution, in my opinion, to send OPC UA data to the cloud. And That's done. Now we can focus on the individual use cases, running different software as a service offerings on Azure. And that's really exciting. If you have any ideas of software that used to run in the factory and now you were consider running it in the cloud, let me know. I'd love to work with you on that. And here are some resources. So fundamentally, .NET Standard, Reference Stack, our ANSI stack and samples, the IoT SDKs, which is like the basic building block for sending any data to IoT Hub. It includes a AMQP, what we call micro AMQP, a very small AMQP implementation that you can use, open source. And then the Gateway SDK as well. It's obviously up there. You can look at that immediately. So now it's for the second part of my talk. It's security considerations. So OPC UA is secure for sure, but you actually got to use it. If you don't, then you might find you have some issues. So I will give you 3 simple rules to follow that will make your OPC UA deployment more secure. Rule number 1, don't talk to strangers. So, like you told your kids when they grew up, don't talk to strangers, the same applies to your OPC UA server. So if you have security mode none enabled on your actual commercial deployment, I'm not saying none doesn't have its value for testing purposes, that may be so, but on a commercial deployment, turn it off, delete it. It doesn't need to be here. So don't talk to strangers. The second part is, don't accept gifts from strangers. Now, I don't know about you, but if my son, who's 3-year-old, would say, Daddy, can I buy candy from this guy? I would say, no. So the problem is, with self-signed certificates, you have no way of knowing if the person who made the certificate is who he said he is. So instead, if you really need to accept self-signed certificates, the least thing you can do is warn the user, because the people on the shop floor that are using your OPC server will not be security experts. They probably don't know what a certificate is. So you need to warn them. So Internet Explorer, for example, does this. It says there's a problem with this website security. We recommend that you close this web page and do not continue to this website. And if you do it anyway, then hopefully you know what you're doing, right? But at least you give the user an explanation of what's happening, right? So to highlight, to really drive home the point here, so I made a security certificate earlier on, and I'm giving it to you. So could you please read it out?
It says in the certificate, it says that my name is Donald Duck, and it's signed by Donald Duck.
Right. Do you trust this certificate?
No.
Why not?
I don't know him. I don't.
You think it's self-signed?
Who is this Donald Duck?
You don't know, right? And that's exactly the same as accepting self-signed certificates on your OPC server. If I give you my passport, would you accept it and say it's the real deal?
Yeah, of course, if it says that you are Donald Duck.
If it says I'm Donald Duck, well, that probably won't happen. But my passport will say I'm Erich Barnstedt, and it's signed by a security certificate authority, the German government in this case, right? So the difference between this piece of paper and my passport is the passport came from a trusted root certificate authority. So my recommendation to you is use a certificate authority for your certificates. Certificates cost money. There's a slight investment required, but it's worth it, because then in the reference implementation, I'm sure all the commercial implementations, you're no longer relying on the person on the shop floor to make the decision to trust whatever server or client is trying to connect to your system, but you are handing off that responsibility to the people who have issued the certificate. And to get a certificate, you need to actually prove your identity. Otherwise, you don't get it. You usually have to, send them a photocopy of a passport or something to really, I suppose, register with the certificate authority and prove who you are, right? So that is my second recommendation. And my third recommendation is don't leave your secrets lying around. So you wouldn't leave your credit card on your desk in work, right?
Of course not.
Why not?
Anybody?
You could just take it, right? So why do you do the same thing with the private keys from your OPC server? Because fundamentally, in a lot of the implementations, they're just stored on the file system, something that the BSI has also said, not so good. So the private key is like a credit card, right? It gives people access to use the certificate from your OPC server if they get access to that PFX file any way they want. They can impersonate you. They can say, I'm really Yuri, and now this is the OPC server, and since you trust Yuri's OPC server, you now trust me. So these things, I've seen the craziest stuff in factories. PFX files and USB sticks just sticking on the front of the machine, or even worse, right? So that is not a good idea. So what can you do? The PFX files are obviously used to store the private key of the certificate, which is used for communication, right? Encryption, decryption. What can you do? So you can do this. You can encrypt your file system. Problem with that is you need OS support. So if the OS doesn't support encrypted file systems, you're back to square one. And the much better choice, in my opinion, is to use this little chip here, the Trusted Platform Module. A lot of the systems that are in factory today already support a TPM, either a discrete TPM like this one here, or built into the CPU. A lot of the modern CPUs actually have TPM support built in. So this is a industry-grade TPM chip. It not only provides secure storage, but it also acts as a cryptographic provider, which means that you can do key generation, not with pseudo-random numbers, but real hardware-based random numbers. A lot harder to hack. You can do signing, decryption, and encryption. You can do all that with this little chip here. How much do you think this costs? Industry grade. $100? Less? More? Less? How much? $25. Anybody want to second that? $1. You're cheating. You probably know this, right? It's $1.50. It's $1.50 on a system that usually costs a couple of $100,000, right? It's a no-brainer. There's no excuse. This backup system here, which is their CX5100 series, has a TPM chip built in. Use it. So that is my third consideration and message to you. Please use the TPM chip. Use the certificate functionality has built in. Use the security principles that are common in the industry today. Please don't build your own security. I've seen this as well. A lot of folks build their own security. It's usually hackable in hours, right? Because you're never going to beat industry standard security protocols with your own ideas. There's a reason why they exist. And with that, I want to thank you for listening to me. And yeah.
Thank you, Eric. Any questions?
Actually, there's one more thing. Finally, somebody's laughing. First time I did this, everybody just looked at me. I think this is pretty funny, so I decided to build it in. So I can tell you now that Microsoft will contribute a TPM certificate store to OPC UA open source. We're working on it right now. If you're really interested in when I check in stuff at 2 a.m., it's here's my fork of the .NET Standard library. What it does right now is it generates a private key pair in software and then stores it in TPM. It's part of provisioning, right? You need to provision the TPM with the certificate. It can then retrieve the private key pair and generate the public key pair from that data. So in RSA, the private key, the public key is derived from the private key. And you can then use it to generate a certificate, right, with your private key, sign it. And then also store for any OPC UA client or server connecting to you. It also stores the certificate thumbprints of those certificates that are handed to you in the TPM, which allows you to verify that nobody has tampered with the certificates that are stored in the file system. So if I wanted to hack a system, I would sneak in the certificate into the right place on the file system. For the public key. So the public key is okay to store in the file system. It's public, right? But at least this way, it prevents me from communicating with servers that I haven't explicitly trusted, right? So it's an additional security measure to prevent hackers cracking my system. So this is, again, this is work in progress. On this particular chip here, I actually have the OPC UA certificate. I just couldn't get my Raspberry Pi working here today, but otherwise I could have shown you. But fundamentally, it's there. It'll be contributed back to the OPC Foundation as soon as it's ready. Things that are still missing from it, obviously, I want to use the generation of private keys from the actual TPM rather than building the private key in software. And I also want to add support for certificate authorities. Otherwise, I'm a hypocrite, right? If I ask you not to use self-signed certificates and I'm using them myself, then that doesn't really make sense, right? So I'm going to add support for certificate authorities. And then the way it works with Global Discovery Server, if I understood it correctly, is you actually generate the certificate, but then send it off to the Global Discovery Server for signing. It comes back signed, and then you use it. So you're actually signing, or the certificate is signed from something or someone that you trust. So that is still to do. Once I'm done, this is going into the .NET Standard Stack. So with that, I'm really at the end of my talk. Any questions?